working of NPN transistor. Working of NPN transistor, that is we have to know. Mostly used transistor is NPN, not Pnp transistor, because mobility of conduction electron is greater than that of the holes. That's why NPN transistor is more efficient than Pnp transistor. Now we can draw the biasing of emitter, collector and base. How to connect external battery to the emitter and collector to produce emitter current, collector current and base current. So again we can draw this diagram. This is the emitter, which has highest majority charge carrier density, and this is the base, and longest part is the collector. Longest part is the collector. And this junction transistor has three terminals. And this terminal is emitter, this terminal is base, and this terminal is collector. Emitter is N-type, and thin part of P-type semiconductor base is sandwiched between N-type emitter and collector. Majority charge carriers in N-type emitter is the conduction electrons. This dot means conduction electrons, and minority charge carriers is hole. In N-type collector we have majority charge carriers, that is conduction electrons, and minority charge carriers are holes. In P-type semiconductor we have holes as majority charge carriers. In P-type base we have holes as majority charge carriers. And this is the emitter. Here what we can denote, this is the emitter which emits majority charge carriers, and this is the collector. This is the collector which collects majority charge carriers from the emitter through the base. And which part is the base? Obviously the thin layer of opposite type of semiconductor is known as the base, which provides proper interaction between the emitter and collector. And in this case emitter is always forward biased. So N-type emitter is always forward biased. That's why N-type emitter should be connected to negative terminal of the battery. So in this way we can connect an external battery. EMF of this battery is VEB. And in this case emitter is always forward biased. Emitter is always forward biased. Emitter is always forward biased with respect to base. Forward biased with respect to the base. With respect to the base. And what about the collector? Under bracket of collector, collector is always reverse biased with respect to the base. Reverse biased with respect to the base under bracket of collector. That's why if we connect a battery, in that case N-type collector should be connected to positive terminal of the external battery. Negative terminal, positive terminal, negative terminal, positive terminal, negative terminal, positive terminal. In this case collector is reverse biased. That's why the battery which will produce the current to the collector will be stronger battery, and this is positive terminal and this is negative terminal of the battery. EMF of this battery is VCB. So this is what the circuit diagram of NPN transistor, and in this case what will be the direction of conduction electrons? Conduction electrons will be repelled towards the base, because this conduction electrons So this is the conduction electrons which will be repelled by the negative terminal of the battery. This is the conduction electrons. This is the conduction electrons or electron which will be repelled towards the base due to this negative terminal of the battery, and this is the positive terminal of the battery. So negative terminal of the battery of EMF VEB will repel the conduction electrons towards the base, and what will be the direction of holes? Holes will be moving away with respect to the base, and holes will be attracted by the negative terminal of the battery. In this case, what will be the direction of current? Current will flow in the opposite direction of motion of conduction electrons. So obviously emitter current will be moving away, flowing away from the emitter, and this current is emitter current IE, which will flow away from the emitter because holes are flowing towards left. That's why emitter current IE will be flowing away from the emitter. In this case, obviously, if we erase these holes, and now we can denote the holes in this position and holes in this position. Conduction electrons. Now we can denote the direction of motion of conduction electrons. Say this conduction electron will cross the base and will reach to the collector. And it will recombine with this hole, and it will produce collector current. Similarly, we can denote the motion of these holes. Holes will be moving away in collector. This conduction electrons will be attracted by the positive terminal of the battery of EMF VCB, and holes will be moving towards the base. In this case, these conduction electrons will cross the base and neutralize with this hole, and it will produce what type of current? A collector current IC. It will produce a collector current IC, and we can denote the direction of current. Holes are traveling in what direction? Holes are traveling towards left, towards the base, and collector current will be flowing in the same direction. So this is the direction of collector current, which is IC, and emitter current is IE. Here we can denote the emitter current, which is IE. Collector current will be flowing in this direction, collector current IC. And in what way base current will be produced? Say this conduction electron will neutralize this hole and producing base current IB, or this conduction electron. So base current will be flowing in what direction? Obviously, base current will be flowing towards the base IB. So this is emitter current IE, and that will flow as IB and IC in this branch. So this is what the working of NPN transistor. Working of NPN transistor. In this case, obviously, collector current IC is a collector current. Collector current will flow in what direction? Will flow into the collector. Similarly, IB is what? The base current. and base current will, and we know that current flows in the opposite direction of motion of electron, and we know that this conduction electron is flowing in this direction, say is flowing in this along this direction. That's why base current will be flowing in the opposite direction. And what about IE? IE is the emitter current. IE is the emitter current, which will flow away from the base current. Emitter current. IE is the emitter current, and which will flow in the same direction of motion of hole. Hole will be moving away from the base because this hole is attracted by the negative terminal of the battery. That's why hole will be moving away from the base. And in this case, what we can see, that means emitter current IE is sum of base current and collector current. Base current and collector current. And also we know that if collector current and base current flow into the collector and base respectively, in that case emitter current will be flowing in the opposite direction, means emitter current will be flowing away from the emitter. If collector current and base current flow into the collector and base respectively, in that case emitter current IE will flow away from the emitter. That's why we can say that IE is sum of IB and IC. Sum of IB and IC, which is the emitter current. Emitter current is the sum of base current and collector current. And for NPN transistor, emitter current flows away from the emitter. Now we can draw in this case we can draw equivalent symbol of NPN transistor. And the most important thing is what? Emitter is always forward biased, collector is always reverse biased with respect to the base. The equivalent circuit diagram will be what? So this horizontal part is base, this is the base, this is the collector and emitter. This terminal is collector and this terminal is base, and this terminal is emitter. We have to draw the diagram again. Now logic symbol of NPN transistor will be what? That is we have to draw. In this case we can draw a circle, and this is a circle, perfect circle, and this horizontal part is the base. And two inclined, these are the two inclined elements. They are actually emitter and collector. This element is collector, this element is base, and we can draw other element of this NPN transistor, that will be emitter. That is the logic symbol of transistor. And we know that emitter is always forward biased, so it should be connected to this type of battery. That means here if it is NPN transistor, NPN transistor, then N type emitter should be connected to negative terminal of the battery. And this EMF of this battery is VEB. And also you can connect a battery, and here collect emitter. Emitter is always forward biased. E is the emitter, which is always forward biased, and C is the collector, which is always reverse biased. Under bracket of collector, what we can write? Reverse biased. And emitter is forward biased. As collector is reverse biased, obviously N-type collector should be connected to positive terminal of the external battery. This terminal is positive terminal and this is negative terminal. And positive terminal of this battery of EMF and this EMF is denoted by VCB. Positive terminal of this battery is connected to N-type collector. So this is the equivalent diagram of NPN transistor. Here what we can write, this is NPN transistor. NPN transistor. NPN transistor. Now we can denote the direction of current. For NPN transistor, emitter current will flow away from the emitter. And in this case, we have to denote an arrow at the end of emitter. This arrow is important. This arrow indicates the motion of direction of flow, direction of motion of majority charge carriers. So always denote this arrow. Always denote this arrow in emitter. And this arrow indicates what? The motion of or direction of motion of majority charge carriers in emitter. So always denote this arrow. And now we have to denote the direction of current, collector current. Collector current is IC, which will flow into the collector, and base current IB, which will flow into the base. So circuit is completed, and in this case additional information is what? So when the conduction electrons, which are the majority charge carriers in emitter, majority charge carriers from the emitter, when the conduction electrons from the emitter under bracket E enter under bracket E enter into the base, enter the base region under bracket B, comma, what will happen? 5% of this conduction electrons, few conduction electrons under bracket only 5% will neutralize the holes, and it is again majority charge carriers in the base, majority charge carriers in the base, comma, which produces base current IB, which produces base current IB, produces the base current IB. Therefore, IB is equal 5% of IE, 5% of emitter current IE, semicolon. That means IB is equal to 0.05 times of IE, 0.05 times of IE. Base current is 0.05 times of IE. This is the base current. This is the base current. This is the base current. And also we can explain in this way. In this case, this conduction electrons, that is the majority charge carriers from the emitter, will enter the base. Obviously, 95% of conduction electrons, 95% will enter the collector, and remaining portion is 5% of this conduction electrons will neutralize the holes. Here we say we have the hole, and conduction electron will neutralize. 5% of conduction electrons coming from emitter will neutralize this hole and producing the base current in this direction. Base current will be flowing in the opposite direction of motion of the conduction electrons. In this way, conduction electrons IB is produced. Similarly, in what way collector current is produced? What fraction of emitter current enters the collector current? Obviously, 0.95 times or 95% of conduction electrons enter the collector and recombine with the holes, producing collector current. And here what we can write, the remaining, here this is the explanation in what way collector current and base current is produced. So the remaining 95% conduction electrons, pass over to collector, the collector from the emitter through the base, pass over to the collector, from the emitter through the base, through the base. Remaining 95% of conduction electrons pass over to the collector from the emitter through the base, producing collector current IC. Producing collector current IC. Therefore, what about IC? IC is 95% of IE, 95% of emitter current IE. Therefore, IC is equal 0.95 times of IE. 0.95 times of IE. Collector current is 0.95 times of IE. And if we explain again, this is the emitter, N-type emitter, and this is the base, which is the thinnest part of junction transistor, and longest part of the junction transistor is collector, and this end is collector end or this terminal, and this terminal is emitter terminal, and the middle terminal is the base terminal. Base is P-type and collector is N-type. We have the conduction electrons and holes in N-type emitter, and also you can denote majority charge carriers as hole in P-type base. these are the holes, and these are conduction electrons, which are the majority charge carriers in N-type collector, and these are minority charge carriers are holes. Now these conduction electrons will migrate from N-type emitter to P-type base, and 5% of these conduction electrons will neutralize the holes in P-type semiconductor. This is 5% of conduction electrons will neutralize the holes in P-type semiconductor, and the remaining portion will enter the N-type collector. That is, remaining portion is 95% of this conduction electrons will enter the collector and producing collector current. As 5% of conduction electrons neutralize the holes in P-type base, so that's why base current is what we can denote. Base current IB will be 0.05 times of emitter current IE. As 95% of conduction electrons enter the collector, that's why it will produce the conduction collector current, and collector current is 0.95 times of emitter current. And so in this way collector current and base current is produced. And also additional information, if we add these two currents, if we add base current and a collector current, then we get what? 0.05 times of IE plus 0.95 times of IE is equal IE only. Sum of base current and collector current is equal to emitter current. IB plus IC is equal to IE, is equal to IE, which is the emitter current. So this is the working of NPN transistor. Working of NPN transistor. And also additional information is what? What does the arrow on the emitter indicate? Additional information. So there is an arrow in what? There is an arrow on the emitter element, and this arrow indicates what? This arrow, which is denoted in on the emitter, indicates the direction of motion of majority charge carriers. Direction of motion of majority charge carriers, or the direction of emitter current. Direction of emitter current. Direction of motion of majority charge carriers in the emitter. Majority charge carriers in emitter. That is the direction of emitter current. Direction of emitter current. And this arrow is denoted in which element? This arrow is denoted in emitter. This is all about NPN transistor. Now we can explain the same working of PNP transistor.